All right, let's do this one. Y equals okay. Do that one. All right, what do you think? Yes, I did that on purpose. There needs to be parentheses. That's the one that really needs it. Now, okay, a couple things. 4 over x. Now, we talked about this the other day. You do not, I mean, you could do a quotient rule with 4 over x, but it unnecessarily complicates it. Anytime you have, if you have 4 over x, you want to write it as 4x to the negative 1. And if you have x over 4, you want to write that as 1/4 x. Not 1/2. 1/4 x. So if you have a constant alone on top, constant alone on the bottom, don't do a quotient rule. That's usually the best strategy. But anyway, so we write this 4x to the negative 1. So that's a power rule. So derivative first would be that. Leave this alone. Plus, this left alone. Now the derivative of this. The rule for 3 to the u is 3 to the u times ln 3 times u prime. So 3 to the u would just be that times the ln 3 times the derivative of the inside. And this is what I see all the time. People put a dot and they're thinking, okay, now I got to do this. They put a dot because they know they're doing the derivative inside. So they put times, and then they're thinking in their head, oh, that's 2x minus 1. They write that 2x minus 1, and then they leave it, and then they miss it. Did all that good work, and now you miss it. Got to have parentheses right there. Okay? And there really isn't anything to do after that. I mean, there's just nothing. I mean, I could take this 4 and distribute it through there, but that doesn't really do anything. Nothing really cancel. I mean, there just isn't anything to do after that. one right there. Okay, let's go to, on the website, Allie, I've got, it is setting out waiting for you in the memos. So whenever you're ready, you just go to it. All right, so, this is from the website. This is practice number 3, I believe. And let's do this one right here. This is from that second website. It was derivative practice number 2 was the link on our website, and it was the Arizona State one, and it had 3 different PDFs, and then the actual test with solutions on it. And this is from number 3. What's that? Absolutely. Matter of fact, what I would say to you is that one of the things we said with implicit is sometimes you get a problem like this, you can get the y by itself. That's an option. But often you can't. This one you cannot. Actually, your only option is implicit because you cannot get the y by itself here because of the one that's inside the sign. So on the gateway test, I'm not even going to give you that option. The ones I give you that are a mixture of x and y, you cannot get the y by itself, so don't even try. So you see a mixture of x and y, it's implicit for sure. Just leave it on my desk. Won't do you any good. Hers is a different version. Nope. I'm showing you. Okay? So 2y prime is the derivative of 2y. The derivative of x squared is 2x. The derivative of sine y is cosine y times a y prime. And remember, we said anytime you're doing a derivative with a y in it, do the normal derivative, but tack on a y prime. Because it's basically doing the derivative of the inside is what you're doing. You're saying, hey, there's some stuff on the inside. We're doing it with respect to x. That's the key. So you got to kick out the derivative of y with respect to x, which is y prime. Okay, then you got to get the y prime terms on one side. Okay, so this cosine y prime, we need to move over there, leave the 2x over there by itself, take out a y prime. And every implicit differentiation problem really looks like this, unless you get a couple like we had in the homework where you had to coil some stuff together because your y prime terms were on the inside of something. So you had to kind of multiply out to get them as separate terms so you could gather all the y primes on one side so you could then factor it out. But that's kind of the key. So 2x over 2 minus cosine y. Okay, what we didn't see in this one is a product rule. Right? It's pretty common to get one where you have a product rule that you have to do. For example, we don't need to actually work the whole thing out here, but if I get an x squared y cubed, let's just say that was in my problem. Okay? Write down the derivative of that real quick. I mean, you're not going to solve. I didn't give you enough to actually solve it, but, you know, there's no equals, there's no other side, and all that stuff. So you're not actually going to get y prime by itself, but just do the product rule on that. Okay, so when we go to do the derivative of the first, it's 2x. We leave the y cubed alone, and then the x, then we reverse that, the x squared left alone, and then when we do the derivative of y cubed, we get 3y squared y prime. Right? Now, a couple things I want to comment on this because this is very common to see on the gateway test. And these are some things I've seen people have difficulty with. Number one, putting the dot in there for the time sign seems to really mess people up. Like you'll put an x squared, then a dot, then the 3y squared, dot, y prime, and for some reason then because those multiplication dots are there, it makes you think you can't move things around or something. And this is what drives me nuts. I hate to see an answer, you know, that's in your final answer, you've got x squared times 3y squared with a dot in there. What do we usually do with the 3 that's stuck in here? It's out in front, right? We always put the coefficient out front, like this 2. We don't stick it there in the middle. And for some reason, when people put those dots in there, that seems to mess them up. As long as there's no plus signs in the middle of this, you don't need that, okay? But I think you ought to, when you see this, you ought to work this out. You ought to have that 3 in front. Matter of fact, if I was doing it, I would say, well, I'm going to leave the x squared alone. Derivative of this is 3y squared. I would just put the 3 in front right away, and then you've got your y prime on there. Okay, just little things like that can help you so that you can simplify it correctly, or, you know, your final answer will be correct. I don't know. I'm baffled by the lack of questions. That's good. Hopefully that means we're going to do really good. Usually I would, well,
we got 7 movie days.
yeah, that's true. If everybody in both classes gets 100%, yeah, we'll see.
You didn't say 100%, you said pass.
Said pass.
Oh, Pamela? Yeah, I'll even go back going.
Yeah, it's on the recording.
Yeah, that's right. I'll even go with
And if
pass.
it doesn't happen, we get 3.
No.
At least.
No.
Is that on that recording? Yeah.
Some trying to think some stuff we talked about, but you guys don't have questions, so I might as well not waste your time. Yes, Mark.
Can we do some with inverse trigonometric?
Let's do it. Here, trigonometric, inverse trigonometric. Here's one right here. Good one. Yep, I do have a couple other little things I did want to mention yet, so we'll do those here, but this is a good one. I did want to do a few of these.
Thanks.
What? Somebody ask a question? Oh, on this one, yes. Great. Yeah, it is a great job. Good job. Finally. Yes. Yeah, I'm not going to give you any of those. I'm not going to give you those.
Which ones?
But like that one on the homework we had, there was arc secant of something, and then we said just flip it inside, and then it's arc cosine. Yeah, but I'm not going to give you those. It'll just be arc sine, arc cosine, arc tangent. Yes.
Are there gonna be any like y equals x squared?
Okay, next question.
3.3, but
Are you guys done with this one already?
yeah.
It is a pretty easy one.
Pretty easy.
All right. That's what I got. Yes.
Would there be anywhere it's like arc cosine and then like that sine and parentheses or something?
No. We in the lesson, in the homework lesson, and on arc sine, arc cosine, we did some of that trig kind of stuff where you had to do unit circle and and those kind of things. Now, I guess with that said, let's take a look at one. If I put an arc cosine inside of a sine, if I tell you to do the derivative, though, it doesn't have anything to do with doing that. The triangle, and they're canceling each other out. I wouldn't even think of them that way, and I wouldn't expect you on this to be able to work that way. Now, let me show you one of those to answer that question. Let me make a comment about this, though. One of the things that we've been trying to be clear, I've been trying to be clear about, is simplifying. What I want you to do, rearranging, that's great if you want to do it, but not necessary. If you can factor and cancel, you should do that. If you can combine some terms, multiply some numbers together, you should do that. To me, the -1 and the 3, you need to do that. That's multiplying two things together that need to be multiplied. That makes -3. So I don't think you should leave it there. The thing I did say, though, I think when we have inside the arc sine, arc cosine, arc tangent, you got this u squared, right? 1 minus u squared. Or in arc tangent, there's not a square root, right? But it's a plus sign. But you've got to know those rules. And I think I did say you didn't need to square this. Now, what I really meant was if there was a 1 plus x in here, let's say, right? If this was arc cosine of 1 plus x, then down here you get 1 plus x quantity squared. I don't know that you have to FOIL that out. Now, it wouldn't be that hard to FOIL. Actually, the ones could actually combine them. So it wouldn't be a bad idea to do it. But so I've been a little bit vague on that. And I know for some of you, you kind of want to know, do I have to do this? Do I not have to do this? Whatever. So in this case, if you left that x cubed squared, to me, that's a real easy one. That should be x to the 6th. Okay? But if you left it x cubed squared, probably not going to take off of that. Again, I said probably. So I've been a little bit vague. There's some of these that you might be a little vague on. Now, well, that's the key. That's what I was going to say. If I wouldn't, do the best you can. Simplify those things that should be simplified. If you're worried that you're going to simplify it and screw it up, then maybe I wouldn't do it. It's possible it's something that I think you should have simplified and been able to do, and you might miss it. But if you thought you were going to screw it up anyway, you were probably going to miss it because you'd have screwed it up, right? So the best thing is obviously be able to do it, be able to simplify and be able to do what you need to do. I will probably be a little lenient in that 7 to 8 range. If this is the one that might make you to go from passing to not passing, on something where I've been a little bit vague, I may be a little more lenient on that. Okay, if it's something where I clearly think, no, we worked on this, we talked about this is something you need to simplify, then it probably will still cost you. Okay? But you can't worry about that. You just got to you got to study for it. Worry about it until you get to the test. Study for it, practice. But once you're on it, you got to do the best you can. That's about all you can do. All right. So I wanted to mention what Mark was just talking about there. This wouldn't be quite that example, but let's take a look at that wouldn't either. but I think what he was mentioning is where we had like arc cosine of sine x. That kind of thing, right? So if you had something like that. Well, we did a thing where we drew the unit circle, we put some stuff in there and did those kind of things. I wouldn't have you do that here. Okay, this would simply be, all right, we're going to do the derivative. The outer function is arc cosine, so that's -1 over the square root of 1 minus the inside squared, which would be sine squared, okay, times the derivative of the inside, which is cosine x. Now, this was actually like one of your homework problems. I think you had to do it. You had to do something similar to this, right? Because, yeah, what's 1 minus sine squared? That's cosine squared. And what's the square root of cosine squared? Cosine. Now, technically, it's absolute value of cosine, okay? We're not going to worry about that on the gateway test, okay? But you would have to do maybe that amount of simplifying. If you forgot to do that, okay, and you get cosine, negative cosine over cosine, and think, well, that's -1, that kind of thing, okay? It does simplify down. So there are some strange things that happen. I'm probably, Mark, going to stay away from that anyway. But what you're not going to have to do is have to be able to do some of that unit circle stuff and those things we practice. We need to know those trig things, just not for the gateway test. All right, let me show you what we did in the other class since you guys aren't going to ask. I don't remember if this is off the website. Somebody asked about this one. I think they'd done it on the website, had some questions about the simplifying aspect of it. So I don't know if you need to write the whole thing down. Maybe write the problem down at least. I won't have it up here long enough, I don't think, for you to write it all down. But this was a problem that had a product rule, so it's very similar to the one we started class with today, okay, with our quotient rule that we have. But it has a product rule up on top, okay? And so I've been talking about how when you have a quotient rule, there's really 4 things up there, or in a product rule, there's 4 things. The derivative of the first, or the derivative of the top, leave the bottom alone, minus top left alone, derivative of the bottom. You got 4 things that'll be in parentheses. Well, the first thing you got to do is then the derivative of the top. Well, that's going to be a mess. That's going to be a product rule. So I put a great big set of parentheses here and did that product rule. Now, what's a log derivative? Well, that's one of the rules we got to know, right? The 5 would just hang out there, but this is 1 over x. So I went ahead and put the 5 with it, 5 over x, times 1 over ln 4, right? I kind of got out of order here because I forgot the 1 over ln 4. This is one of the things I was telling you I made a mistake on this morning. Because the rule for log base 4 says you got a 1 over ln 4. Then we leave the x cubed alone, so that's in there, plus the 5 log 4 left alone, times the derivative of x cubed, which would be 3x squared. So all of that was just the product rule, doing the derivative of the top. Now I got to leave the bottom alone, which is 2 to the x, minus the top left alone, which is an x cubed. I forgot that. That was the other thing I screwed up. Forgot the x cubed, and then the 5 log 4, so I just leave the top alone, times the derivative of the bottom. Derivative of 2 to the x is 2 to the x times ln 2. And then the bottom squared. So then the question was, where does this simplify? Well, you've got a 2 to the x right here, and you've got a 2 to the x right here. And I think that's about it. And also right here. What about this right here? 5, I'm going to give you guys a chance to practice one like this, but that's 5x squared, right? Because this x cancels one of those. So you get 5x squared. I put the ln 4 on the bottom. Also, this 5 times this 3, right? Now, there's a plus sign in between, so we got to be careful with these 2 red things. But those I can put together, and then these I can put together. So 5 times 3 is 15. Okay, and there's a 2 to the x. Now, there's a 2 to the x over here also. So if I take those 2 to the x's and factor them out of the whole top, then I can cancel with one of the 2 to the x's down here. So that's what I did when I scribbled those out. Okay? So that was another one that gets into some, some simplified. But remember, they're not all going to be that way. Okay? If I go ahead to another one I did, this is one that they asked about. They had tangent of some stuff, and it's got a quotient rule inside of it. Well, the derivative of tangent is secant squared. Leave the inside alone, times the derivative of the inside. And when we did this quotient rule right here, there was really nothing to do. Just did the quotient rule, and it just kind of Nothing can be simplified, nothing can be factored out or anything. You can't cancel this 1 plus x squared to that 1 plus x squared. That doesn't work because 1 plus x squared has got to be part of this term over here. So you can factor it out, which we can't do. Okay? So there's just nothing. So often that happens. There's just nothing to do. All right. I wanted to do this one. I want to add a little bit to it here, though. Okay? All right. Do that problem right there. This will be the last one, and then I'll give you some work time. What's that? She did. Didn't take very long. Thought it was easy. Because you were so responsible and did it ahead of time, I gave you a lot easier one than they're going to have. Just don't tell them. What's that? Yeah, because you're not really being penalized for taking a long time. You're just, yeah, and by the way, yeah, on the gateway tests. Now, if you pass the first one, I should have those graded tomorrow afternoon by the time school's out. And so it'll be in the grade book. It'll either be blank. Well, actually, I think what I started doing last year, I'll put in I'll put in how many you got out of 10. I think that's what I'll do. I won't have it calculated into the final grade. Or maybe no. What I'll do is I'll have two entries. I'll have the grade, and I'll have how many you got out of 10. And how many you got out of 10 will not count in the grade book. So you'll see how many you got. Okay, and then if you did get 8, 9, or 10, then there'll be a 30 out of 30 in the grade column. Otherwise, the grade column will be blank. I think that's probably how I'll do All right, let me finish writing this out and then. I think I got this right. Oh. I guess you've been watching me do that the whole time. I thought I had it frozen. Okay. So a couple things I wanted to point out here. Again, wanted to reiterate the thing with the sign squared, that means the whole quantity squared, or the cosecant in this case. The other one was this thing with fractions, because I have done, Ryan asked if there was going to be y equals x squared. Well, that's a pretty simple power rule, but, just to add a little bit to it, maybe I put some fractions in there. It still should be an easy one, but then people can't multiply fractions. Right? When you have no calculator of any kind, right? And so when you bring down to 4/5, you didn't use your calculator, right?
No.
Okay. When you bring down to 4/5, multiply. Except when you took your phone out to take a picture of the test to send everybody. Other than that. So you bring the 4/5 down in front. Remember, when you multiply fractions, you just multiply straight across. Now you can cancel diagonally if you want to, but multiply across would be 12/10, which would reduce to 6/5. So 6/5, subtract 1, x and -1/5. This, you gotta bring the 2 down in front. Leave the inside alone. This is the part that people forget. You gotta bring the 2 down in front. Leave the inside alone. Drop to 1. Now you do the derivative inside, which is cosecant. Derivative of cosecant is negative cosecant times cotangent. Times its inside, the derivative of that inside, which is a 2, and that 2's got to stay in there too. When I wrote this, I wrote a big set of parentheses here because I knew when I do the derivative inside with cosecant, I remember that's got several parts to it. So I put those parentheses, and so I remember to get all that inside there. Okay? And then over here, I got a product rule, so 1 times log left alone, and then x left alone, and then 1 over x, 1 over ln3. And the reason I wanted to write that one is because whenever you do a log, it's got x's in it. A lot of times, if there's other x's in the problem, then you get some canceling. In this case, you can't. Okay, so when we simplify here, this x cancels with that x. You've got to do that. Okay? And so that'd just be a 1 over ln3. You'd have the log here. Here we can put a bunch of stuff together because this is all stuff that's multiplied. There aren't any plus signs in here. So this 2 times this 2, the negative would turn to positive 4. Cosecant times cosecant would make cosecant squared. Cotangent. Okay, so there's a lot of stuff you could put together on that one as well. All right, so I think that hits everything I wanted to. We've got some implicit differentiation there. We did some of the inverse trig. We got some of these other ones reviewed. Talked about simplifying on some quotient rule. Just got practice. Practice. Okay, so let's go to work. Go to work. You can get on the website if you want to. You can get back on page 195, do some of those. Let's just spend the rest of the time practicing for the last half hour or so. And again, come up and ask me individually, right? If you've been working on some, you didn't want to ask about it in front of everybody else, and you want me to check it over for you, do that. That derivative practice 3 on that Arizona website and practice 2 have a lot of good ones, right? They've got a lot of quotient rule and some product rule ones. There's, some of those would all be good ones. Good ones to do. Here's some up on the board if you want to do those. Yes, whoops. Yes.
Okay. So am I going to get 47 points from Cobb, Nelson, Lacey, and Crosby? Yes or no? Nelson, Cobb, Lacey, and Crosby. Yes. 47.
Who they playing?
Falcons.
Where at?
I don't know.
I would say so.
Solid.
Yes.
Is that mine? Which test do you think is best?
I think that the one where the PDFs, this one, yeah, number 2, and go to page 2 and page 3
On it?
on it. Yeah, there's like 1, 2, and 3. I think
So, like, don't
that's
even
where I
do
would
this
go. Well, no, this one's derivative practice too.
Yeah.
So there's when you go to the website, it's that's the wrong one. It's where's my oh wait. Stop.